So the inverse of a power is a logarithm. How do we find an inverse? Graphically, you just switch the x and the y. So if we think back to our graphs, here's the graph of y equals 10 to the x. It would have the point 0, 1 and 1, 10. If I switched x and y and reflected over the line y equals x, I'd get the point 1, 0 and 10, 1. And we call this graph y equals log base 10 of x. And the log with base 10 is called the common log. And the common log, since it happens often, you do not have to write the 10. So whenever you see log of something with nothing written as a base, there's a base of 10 there. We look at points on our exponential graph, like 0, 1, 1, 10, 2, 100. Those points, because it's an inverse, you switch the x and y. That's what they would be on log base 10 of x. And at the bottom of the page, we have the definition of a logarithm. And I would like you to write this down with those exact numbers. And what this means is that if you have something in exponential form, you can write it as a logarithm. So an example that we had before was we were asking 7 to what power is equal to 30 in exponential form. Then in log form, it would be log base 7 of 30 equals x. And this is the power of the log form, is the log form gets the exponent, in this case the x, all by itself. And on some of your calculators, you're going to be able to type log base 7 of 30. So on my graphing calculator, I can either hit the math button and scroll all the way down to log base. I can push log base 7 of 30. If you have an older graphing calculator, it won't have this. So if you have a TI-83, it won't work. A TI-84 with the newest operating system will have it. You either through the math button or your alpha keys up at the top. So alpha F1 gives you your fraction button. Alpha F2 gives you another list of things. Log base is number 5. You could type it there as well. Interestingly, if you just have a regular scientific calculator, it only has probably the regular log button. But I'm going to show you, and we'll explain this later, why this works. But if you do log of 30 divided by log of 7, you get the same answer. So if you find that interesting, you can write that down as well. That would also equal x, and that allows you to do it if you don't have the log base on your calculator. Now, this definition of the logarithm, changing from exponential form to log form is of extreme importance that you understand it completely and have it memorized. What goes where? Where does the exponent go? Where does the base go? Where does the answer go? So I'm going to give you a minute right now for you to think about it, memorize the definition of the logarithm. Go to example 1 and use the definition to change the exponential expressions to log expressions. See if you can do it without looking. And the log expressions to exponential expressions. All right, let's see how you did. So this first one will be log base 3 of 27 equals 3. This next one will be log base 5 of 1 over 25 equals negative 2. And the last one will be log base 4 of 1 equals 0. One of the things that, for me, I find really helps me remember the definition of the logarithm is the key idea that a logarithm solves for exponents. So, if the exponent is 3, that's what the logarithm solves for. The exponent of negative 2, that's what's by itself. The exponent of 0, that's what's by itself. If you know that, and that the base of the exponent is the same as the base of the logarithm, you basically, everything else just falls into place. So logarithms solve for exponents. So when I have these in log forms, those numbers right there have to be exponents. So changing these, 7 squared equals 49. That makes sense. 4 to the exponent of negative 3 is 1 over 64. And 10 to the exponent of negative 4 is 1 over 10,000. And what we're going to start to look at next is figuring out logarithms. So this was written out for you, log 7 of 49 equals 2, and when you change it to exponential form, you're like, that makes sense. It doesn't quite make sense because we're not used to it yet when looking at it as a logarithm. So if I had given you this, log 7 of 49, and said, hey, what's that equal to? Our brains aren't used to that yet, okay? But if you're thinking, hey, logs solve for exponents, when I'm evaluating something like this, I don't necessarily write it in exponential form, because it's helpful, but it takes some time. I tell myself, logs solve for exponents. So I imagine a little question mark right here, and say, could I figure that out? 7 to what exponent would be 49? And then it's easy to evaluate. So we're going to get these questions where I'm like, okay, could you tell me from your powers chart, what's this equal to? Log solve for exponents. So you're really thinking in your powers chart, 3 to what exponent is 81? And it's 4. So taking our moment to memorize the definition of a logarithm is really going to help you understand this unit. Okay, questions that you can circle on this one are 5, 6, and 8.